Is air suspension truly more advanced? Why was it only on million-dollar luxury cars before, but now 200 and 300k EVs can have it? Air suspension isn't truly a suspension system, it just replaces the original steel springs with air springs. The chassis still relies on familiar setups like McPherson, multi-link, and double wishbone. Air springs are essentially 4 airbags. The compressor is responsible for inflating these airbags, but it's not directly connected to them. Instead, it pre-fills an air tank, which avoids frequent starts and stops, allowing for on-demand inflation. The air tank's inlet has a check valve to prevent air backflow to the compressor. The tank body also has a solenoid valve to control the inflation and deflation of each airbag, and the solenoid valve is controlled by sensors and the electronic control unit, ECU. Sensors continuously monitor the car's height and speed. The ECU assesses driving conditions and sends commands to the air springs, suspension, and CDC. For instance, when driving smoothly at high speeds, the ECU deflates the airbags to lower the vehicle body, reducing its center of gravity and wind resistance. Simultaneously, it instructs the CDC to stiffen the suspension, ensuring high-speed stability. When the load increases, the airbags inflate, returning the vehicle to its original height and maintaining stability. On bumpy roads, airbags inflate, raising the car body, improving passability. CDC softens the suspension, filtering out road vibrations. You'll realize by now, airbags mainly control height and basic support. In other words, air springs determine the experience's lower limit, but what truly improves comfort is CDC. So the question arises, why replace traditional steel springs with air springs? Because springs determine the suspension's fundamental support characteristics. Soft springs allow the wheels to absorb road vibrations, while the body remains steady. Stiffer springs provide greater support and quicker wheel response, making it more stable at high speeds, with heavy loads or when cornering. In terms of adjusting their firmness and softness, air springs are naturally more capable than steel springs. This is primarily because air has greater compressibility, and by altering the airbag's volume or pressure, various elastic effects can be achieved. Furthermore, a single airbag can also provide a soft initial response and a firmer later stage. It's much like using a bicycle pump. It's quite easy to push down initially, but the further you press, the more effort it requires. Small vibrations are easily absorbed. Large compressions support the body better than 2 stacked steel springs with different damping. Of course, air suspension also has grades. If a single-chamber air suspension needs to maintain body height, its stiffness is hard to control, so it must work with CDC. Dual-chamber air suspension, however, uses a solenoid valve to divide the air spring into 2 chambers. When the valve opens, the 2 chambers connect, increasing volume, making it easier to compress, and the spring softer. With the solenoid valve closed, only the main chamber functions, stiffening the spring. Luxury cars' 3-chamber air suspension offers more refined modes, but because air suspension has so much flexibility, volume, pressure, and inflation-deflation strategies all impact the vehicle, making it highly dependent on tuning. This is why the air suspension on a 200,000 car differs greatly from that on a million-dollar luxury vehicle. What's more, the air spring's rubber bladder ages easily, and its replacement cost is higher. This is also why air suspension can't fully replace traditional setups.